Okay, June 2013, question 4 is a travelling salesman, I think. Okay, mobile hairdresser, she wants to visit. So she decides to visit places in order. So A, again, they like to see you write A in the corner and what you're doing. So she starts at A. There's no to or from here, so it doesn't matter which way you go. You can recognise that as well because it's symmetrical around that diagonal line. So if you're going from, so it's easier for me necessarily to write A to B to C to D to E to F to A. Personally, so I've written that down, A, B, C, D, E, F, A. So from A to B is 15. From B to C is 13. From C to D is 10. From D to E is 26. And from E to F is 27. And then from F to A is 12. Add all that up, you should end up with 103. Okay, that's the first answer. 1 mark, not much. B. This is your classic. Explain why this answer can be considered as an upper bound for a minimum travelling time of Sarah's tour. The main reason being is that any tour is an upper bound. Okay, there's 1 mark. But the last bit is that, and it may be improved upon. Oh. Maybe not even and. Maybe a comma. It may be improved upon. Okay, so that's your classic answer that's in the books. 2 points. Any tour is an upper bound. It may be able to improve it. It isn't definitely. It might be possible. It's not a definite. It can't be. It could be improved. It would be improved. It may be possible to improve upon it. Use nearest neighbour algorithm. In nearest neighbour, you don't necessarily have to use a table. And I can see down here as well, they're going to tell me to do a minimum travelling time. So I'm going to have to do prims on the table. If they give you both, that's great. But the reality is they might not. So think about it. Nearest neighbour is literally, I'm going from this one to this one to this one. So use nearest neighbour from A. So I'm going to go from A. So I'm looking down A. I want to go to the shortest place, which is C. So I'm going to go to C, and that's 11. From C, I want to go, but I suppose I've already done A. From C, I know I'm not going to go to A, so I need to go to the shortest one, which happens to be D, which is 10. From D, I'm not going to go to A and C, but I need to go to the other shortest one, which turns out to be F at 15. From F, I know I've been to A, so I've got B, I've been to C and D, or E. So I think I'm stuck with from F to go to B, which is also 15. From B, I've been to A, I'm not going back yet, am I? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 1 more. So A, B, C, D, E, F. So I've got E to go to. It's the only one I've got left, which is 24. And from E, to make it a tour, I've got to get back to A. So I'm at E. I want to go to A, and that's 27. Add all those up, and you get the answer 102. Right, so that's my nearest algorithm from nearest neighbour from there. And having had my other tour, so any tour is an upper bound, but this one, the lowest upper bound, is the best one. So that would be my best one at the moment. By D, it says deleting A. So I'm going to use the table now, and I'm going to delete A from it completely. Now I'm going to use a different coloured pen, hopefully, to get this sorted. So it says, find a lower bound for the minimum travelling time of Sarah's tour. I need to do a minimum spanning tree on the 4 once I've deleted that node. So it doesn't matter where I start, obviously, because minimum spanning trees, it doesn't, because you end up with the same answer whether you use Kruskal or prims. But I'm going to use prims on this table. So I'm going to start here at B, so I'm going to cross B out. From here, I look down here and I can see 13. So I'm just to keep myself organised, I'm going to write B to C. Okay, and underneath, oops, I'm going to get rid of that. I'm going to do B to C, and I've got 13. Okay, I'm going to cross out C, put 2 above C. I'm going to look down both of them. So I've got these to go through. That one's the smallest. So C to D is 12. So C to, no, it's 10. Good I am. So C to D is 10, cross out 10, put a 3 above D. Looking down all 3, I've got these left, so I'm going to go for this one, which is F, which is C to F is 12. Cross out F, put the next number above F, which is 4. Looking down this, looking along here, because I've only got these to go to, the smallest one is that one, so it's actually C to E. And that is 19. Okay, that is my minimum spanning tree, finished off properly in Prim style. Next thing is, obviously they were looking for the lower bound, so I have to add A back in. So with magic that I have, my pen, I'm going to look at A and think, right, I need to add 2 back in. So A could be here somewhere, and I want to add the 2 smallest, which happen to be 11 and 12, hopefully. So 11 would go to C, and 12 goes to F. So even before this, it was never going to be a minimum spanning tree, but it's worthwhile thinking about it. So the minimum spanning tree would be 13 plus 10 plus 12 plus 19. Get an answer for that. And the extra bit you're going to add on is 11 and 12. And that, I believe, comes up with the answer 77. Hopefully it does. 10, 20, 30, 40, 50. There you go. So 54 plus 11 and 12 gives you 77, which is good. So that would be my lower bound. And then it says, Sarah thinks that she can reduce her travelling time to 75 minutes. Explain why. Well, the minimum tour has got to be greater than or equal to 77, because basically that isn't a tour, so a tour would have to be bigger than that. There's no way it could be smaller than that, because this is what we've got for this one, deleting A. And that's it.